That's how it acts when the battery's low. It's when the battery falls off the back, I put it up really. We're trying to keep the battery from falling.
So it turns out the problem actually was a battery. I was afraid, so Nathan let us borrow his.
Even in industry, battery is always an issue. If you look at Tesla, some autonomous cars, even your mobile device, like
really sensitive.
Yes. All right, so we're gonna try again. Okay. No.
Press the button.
All right, we're gonna try again.
Everybody quiet.
The microphone is really sensitive because we have it set to if it detects 35 decibels or higher, then it will go.
Press the restart button.
Do you want to plug it automatically yourself?
I know, but he keeps plugging in and plugging it because it's so sensitive now.
Quietly, very quietly, I put Maxine down. Okay, so we're going to re-demonstrate Maxine. Here we go. 35 decibels, and it will
Start in the middle. Dang!
There we go. So now, oh. Here we go. You're a little too close to the so she can't destroy a wall. So she will destroy these walls. But
because the battery has more power. The battery has more power, so now she's not turning it on.
Turn, Maxine. Come on, Maxine. All right, so that's that. So we'll go ahead and. Did you guys talk about the code yet? All right. So yeah, that's that.
Yeah, she texts a lot.
Yeah. Well, are you guys nice?
We destroyed your walls, so I'm sorry, man.
It's alright, we're fine.
Easily repaired.
When she detects a wall, the lights turn red. I don't know if you guys know.
when it touches the wall, the light
Turn red. And then she's supposed to turn
So
inside.
they LED more, a different color.
Great. Yeah, they actually go to these.
Thank you. I really like the animation. That's the part, right?
No, you can. I wasn't prepared for the slideshow. No. So we did the line tracker. Our additional feature was to add on the ultrasonic sensor to be able to have object detection. We implemented a pivot function, so that way once it detects an object within a certain distance, it'll pivot away from it, and then it'll have to track back into the line. Unfortunately, I haven't been able to get the line tracking, the search algorithm to find the line again to work very well, so it's not very optimal. It doesn't work very well, but I do have a video of it working at least once. So yeah, it detects an object within 4 centimeters, and then it will turn to the left and then come back. So, demo. I also think the batteries might be good. So yeah, that's about as good as it's gonna get. Yeah, I have to work on the search algorithm to find back onto the line. So. No, it should theoretically work right now. Yeah, it should. I've done a cup in a box. I've only got to work once with a cup. So I'll put that to you.
How do you make sure it doesn't deviate away from the obstacle?
Once it no longer detects the object, it's meant to turn the opposite direction. Yeah, it's supposed to turn right.
It has a delay. Right.
Oh, awesome.
It's
That's amazing. I know, but this is connected to, you can connect this to the, oh, let me switch to this computer. Awesome.
There you go.
Okay, good.
Hi class, thanks to our TA. Now we have real-time streaming of the video, so we don't have to, fly to the front, so you can see the demo through the video, real-time video. Awesome. Where's the camera?
It's my phone.
Oh, your phone. Okay. Okay, so where are we now? The next group is group 4, right?
Yeah.
Wow.
You guys gonna pass right there. This is the Wi-Fi.
They're like 20 points.
Okay, so before I get the code pulled up, we used 4 of the obstacle avoidance sensors, the IR. So, they have the difficulties of not reacting on black because the black just absorbs all the IR. We have the 2 for their step functions. So, it detects, like the step off, like the edge detection. And then we have the 2 obstacle avoidance. We use IR as well. In the beginning, we tried to get the ultrasonic to work, but we ran into it just only works correctly when it was connected to the computer. And so we switched to these, and then we just never switched back. It probably worked since we got the 9-volt battery connection, and then sometimes we also still use the 4.8 volts supplied by the rechargeable batteries as well. So we have a total of like 13. 13.8? Yeah, 13.8 volts. And it still surprisingly drained pretty quickly, even though I thought it wouldn't. And we're going to show you some of our code. Why love it as long as it can look like. So we can just go through this right now. I'll give you 10 seconds to load your video at this point. Okay, we're ready. 5, 4, 3, 2, 1. Oh, it's about 4 seconds off. So we still have the spiral going. Oh, crap. What was that?
Yeah, the stepper function.
Wait, it's still active?
Yeah,
I thought we commented it out.
it looks like it's just the left one.
So to avoid the black lines, I thought I uploaded the code that was commented out. Because I just commented out like a few of the stepper functions, but I guess the black line is freaking it out.
I think overall it's doing well. It's going through every area.
And I don't know if you guys saw it, once both sensors hit, it actually backs up and it continues on what it's supposed to do.
Oh, it gets stuck on the tape. Oh, okay. Uh-huh. So yeah, when both sensors get activated at the same time, it'll back up because it knows it's in a corner, or it thinks it's in a corner. Otherwise, it's just going to curve around. And then I also implemented a timer where if it gets stuck like doing the curve left for the sensor and it goes in a circle, it'll only do it for 2.5 seconds until it sends it out of that loop, and it'll start either going in a default straight path or it starts doing the spiral again. So if it knows it's in like if it goes straight for 2.5 seconds, it doesn't need to keep going in a circle for the same path. It's going to start doing other motions. And then also I implemented a counter, so if it's going around the wall like 7 times, or 12, I forget what I said it for, it'll also go out of that loop as well, and then start going into a different area of the room as well.
You have the video?
We ready for the presentation? Slides? And then let's also test this on a desk as well. Yeah,
And so most of our specs use our Arduino board, our Remoto. We use 4 optical avoidance, a whole bunch of wires, and we originally had 2 batteries because it wasn't strong enough, but when we used that new battery, we actually didn't need the 4 AA's. And as you guys saw, if it gradually at the beginning increases the speed so that way it hits everything. If both the right or the left is sent, it will stop and rotate in the opposite direction that it hit, and then curve back in the previous direction that it was going. And as you guys saw, if both sensors in the front are detected, it will back up and rotate and continue in the previous direction it was in.
And similar to as the sensors for the optical avoidance, the step will do the same thing. So it detects the step on the right side, it will rotate on the left towards the left side, and then curve slightly to the right again, like at the whole edge of the wall or something. And the same thing on the left side, if it detects it on the left side, it rotates to the right, and rotates back to get the whole edge.
Yeah, so on the left, we see that's my spiral function. So I set the right tire at 220, and both wheels go forward, and then over the loop, it keeps on incrementing the speed I, which is set to the left wheel, to get faster and faster. We ran into the problem of it not covering enough ground. We'll show you the step function as well, but it didn't cover enough ground. Like it would start going like this and then spiral out too big, so we had to delay it more. Yeah, so we had to delay it more, but we couldn't delay it proportionally to it, so we had to delay it exponentially according to the speed it was going, because we wanted it to go on the speed for a faster or longer amount of time. So I just set it to we multiplied, or just set it to the power of 1.7, and then added that to the timer. So we wouldn't want to use delays, because then it's not checking the sensors. So I set it to check the not real time, but how long the program's been running for time on the system. And then it keeps on adding that stepper time to the timer. And then as soon as that other time is greater than the time that I set for like the delay, then it goes through this loop again. And I only wanted it to go up to like 220, so like prevent battery drain, and also I just didn't need it to go that fast. Yeah, and then we have the states. So I have a function read sensors, and it'll just go into and read all the sensors. I didn't want to do it like infinitely fast, so I just set it for like delaying 25 milliseconds in there. And then it'll return an integer, 0 through 5, either if there's no sensor being read, if both sensors are being read, if the left or right ones, or the left and right step are being read, and then it does different things. You can see like the left obstacle and the left step are pretty much the same thing. It just rotates right when it detects something on the left, so it avoids that part, and then it curves to the left, so it can keep on curving around an edge, a wall, or a step. And hopefully these steps work. We'll see if it falls off. And yeah, you want to talk about some of that?
The difficulty I think we both had originally was we were using the L2 P3D chip, and I was able to get it to run. Luckily enough, they had the Arduino. Another difficulty we had was battery power. Before we implemented the interrupt, it was really depleting the batteries, so that's why we were using both. I didn't. I'm gonna turn up the code.
Oh, the code problems?
Yeah.
I think I already mentioned it. We ran into the spiral problems, and we ran into like the Arduino, the ultrasonic not working unless it was connected to the computer. Yeah.
That's all. Yeah.
Let's show off the step function. So it's going to do spiral, and then it just takes the right step, and then it needs to detect obstacles over here. Oh. Oh, now this one's always active. Okay. Okay. You guys see the picture? And safely return.